Oh, hey there. What you up to, Megan?
Oh, hey. Just taking some photos.
I thought you liked physics. Isn't photography just a type of art?
Let me explain to you the physics of this camera sensor, and I'll let you decide whether photography is physics or just art. This sensor is called a CMOS sensor, which stands for Complementary Metal Oxide Semiconductor. It contains 24 million pixels or 24 megapixels. Each one of those is made up of a silicone photodiode and an amplifier. The crystal structure of silicone is such that in its intrinsic form, there's no free flow of electrons because silicone has 4 valence electrons and each one of those is paired with a neighboring silicone. But when you replace the center atom with boron with 3 valence electrons, then you get what is called a hole, and that creates a p-type semiconductor. If you replace that central atom with phosphorus or arsenic, both containing 5 valence electrons, then you're going to end up with an extra electron, and that creates what's called an n-type semiconductor. By sticking the p and n-type semiconductors together, we get a p-n junction diode, which promotes the transfer of electrons and holes back and forth across the p-n junction in a process that is called diffusion. Photoconductors are connected in reverse bias, so the positive anode is connected to the positive n-type part of the semiconductor. The negative cathode is connected to the negative p-type semiconductor. This setup inhibits the flow of charge and instead builds up charge on both sides of the semiconductors. Now when light comes in and strikes this sensor, a phenomenon called the photoelectric effect occurs, and photons dislodge electrons from the surface of the semiconductor. And those electrons are now freed and able to flow towards the positive n-type side of the photodiode, while a positive charge accumulates on the p-type side. The intensity of light which strikes each pixel is proportional to the number of photons that are incident on the semiconductor, and there is a concept called quantum efficiency, which says in this camera specifically that for every 10 photons that hit the pixel, 5.6 electrons are freed within the semiconductor. The charge buildup in the semiconductor is now converted into a voltage by a capacitor and then converted again into an output voltage, which contains light intensity information in a set of binary numbers by a readout transistor, and then that signal is relayed to the central processing unit of the camera to be reconstructed into an image. So that's how camera sensor works, and I would argue that that is a lot more than just art, but that the physics behind this thing are actually pretty incredible. Is actually, frick, grammar!